Hi, this is Siddharth from Team Digit, and today I'm here with Dr. Brandt. He's one of the foremost experts on 3D printing, and he's a futurist with Autodesk.
Thank you. I have an incredibly fun job of thinking about the future of designing and making things. So at Autodesk, obviously historically we've been in the design and simulation space, and quickly moving more into the manufacturing and construction side of things as well. And I see all of these aspects of the design and simulation and the actual building and manufacturing of things converging. So I kind of look at this convergence, and that involves a lot of trends, from robotics and automation to artificial intelligence, 3D printing, the Internet of Things. All of these have influence on the way that we'll design and make things.
The concept that I wanted to actually know more about was distributed manufacturing systems. What exactly does that mean?
It's one of the topics that I was here at Inc. to speak about. And the idea is, instead of having centralized large factories, that we can actually distribute factories in a much smaller, compact version and enable more local and regional production. And there's some trends that are enabling this to happen. So from the macroeconomic point of view, you have now companies looking to position manufacturing much closer to the consumer. An example of that would be Foxconn is building their next largest factory. Foxconn, who manufactures all of these, right? Is positioning their next largest factory in Indonesia. And it's not because the wages are cheaper or the regulatory environment is better. I mean, those are aspects, but the biggest reason is because their next largest market is in Indonesia. And this trend we see continuing. We are collaborating with Katie George and her team at McKinsey Consulting, and they've shown that the two primary drivers for positioning factories is proximity to demand and being part of an innovation ecosystem. So ensuring that there's the talent and skill set in that area to augment the supply chain. So from the big perspective, that is enabling this idea of more local or regional production. Now, from the ground up, you have things like the maker movement, with increasing capacity for people to design and make their own things. You have 3D printing, which gives you the technology to now design and make your own things. So we see the convergence again now from the large-scale enterprise and from the individual and maker communities coming together, and all of this nets out at a more local design and production method.
Where do you see the Indian maker movement heading?
Well, I think it is incredibly exciting now. I mean, this is my first time in India, and just traveling around Mumbai for the last few days, you see the resourcefulness of people. So whereas maybe the wealth distribution seems to be skewed,
Very skewed.
the resourcefulness of the people is absolutely amazing, right? If you need something and you can't afford to buy it, you figure out how to make it or how to modify something to enable you to solve whatever problem that you have at hand. You need to tap into that creative capacity. And a lot of that is access to the tools. Obviously, education is a big aspect of this. But I think, just access to the tools and the materials alone could go a long ways. You don't necessarily need the formal education. That's what the internet's for, right? You can learn the skill set that you need. So I would think that you guys are incredibly excited about the future of making in India. And not to mention the fact that the needs of people are unique, right? There's kind of been this truism since the Second World War of industrialization that industrialized economies produce a lot of the advanced products for the rest of the world. And the truth is, those industrialized economies probably don't know about the local needs in Mumbai, for example. So it makes sense for people to actually be empowered to make their own things.
Absolutely, yeah. An offshoot of this question, because we've been talking about in Digit Magazine at least, we've been talking about 3D printing as the next big thing for at least 2 years now. And the way people are talking about, say, drones today, you'll have drones, hundreds and thousands of drones like just flying about everywhere. 3D printing was hailed as that, right? Just about 2 years ago. But it hasn't become a household phenomenon yet. So why do you think that is? And will that ever happen?
It will happen eventually. You have to give it time. I mean, you think of the typical hype cycle where we over-anticipate the growth and productization of certain technologies, And about 2 years ago, we hit the peak of the hype cycle around consumer 3D printing, that it's going to be in every home and all these other grand expectations. And there's a lot of problems, I think, preventing that from happening today. One of them is the reliability of the hardware. Anyone who has a 3D printer, like I said, personally I have 3, and 2 of those printers are used to make spare parts for the third one. The reliability isn't there, the repeatability isn't there, so it requires an engineering kind of troubleshooting mentality, which most people don't have time to deal with. So the hardware needs to evolve, but I think what we don't popularly recognize is the fact that it's already transforming the way that we manufacture things. It's not a do we print it or do we manufacture it traditionally. We're used printing to make traditional manufacturing more efficient. And big industry is already doing this. And there's been parts flying on aircraft for over a decade now. The F-18 has laser-sintered parts, I think, for the last 12 years. Commercial aircraft now have 3D printed parts. And if you go into factories, you see 3D printing making its way into making fixtures so that humans are more efficient. And one of the big success stories is around injection molding, right? So the method that you use to produce small plastic parts, most of the stuff that we have in this room, your digital devices, injection molding produces units in volumes of millions per year. It's very fast, it's very efficient, there's already a lot of capital invested in that equipment, and it's hard for 3D printing to replace that. But what they're doing is augmenting traditional manufacturing with 3D printed tools. So they're printing the molds that go into the injection molding machines. And they can print these molds with internal cooling channels. And it's analogous to like the capillaries in your skin. It goes close to the surface of the mold. It means that they can cool the surface down much more quickly and get more productivity out of these machines. So this industry, which has been trying to get 1% improvement for the last 3 decades, is almost overnight getting 20 to 30% production rate improvements from 3D printing to tooling. So I think over the next decade, you're going to continue to see traditional manufacturing being augmented and improved by 3D printing as consumer 3D printing comes online. So right now it's kind of a niche area, and it'll remain that way for a while until the machines become more reliable. The software is easier to use for everyone. So it'll come along, but I think the industrial manufacturing is really where it's at today.
This was part of my next question, which was, until you make the whole process of 3D printing extremely convenient, the sort of industrial revolution that we are envisioning, and lots of industry commentators are also, it's not happening, right? It's a little more restrictive. There are sort of entry barriers. You have to have a certain amount of technical know-how. So you think it'll be truly democratized soon because of the software, maybe?
Yeah, I think it actually in many ways already is. We launched a consumer division a few years ago, particularly for that, not just 3D printing, but for makers in general, to make the tools more accessible, so that you don't have to be a professional engineer or architect or designer to use the software. And that can range from entry level, you start with an existing template model and just modify it into what you want, to just making primitives modeling and solid modeling easier to use. And what's interesting when you find smaller kids or younger generation adapt to that very quickly. The gaming generation adapts to that very quickly. So it kind of proves that if you build it, that people will use it, and they'll use it to actually physically produce things. So that democratization is underway now. I think the software side is in many ways more advanced in terms of accessibility than the 3D printing hardware side. And that's part of the reason that we've announced that we're building a 3D printer and building the platform to support those printers, to make sure that the software world and the hardware world are merged.
Okay. What exactly is 4D printing? You had 4D mentioned in the brief that was sent to me, so I really have no idea what 4D printing is.
Well, 4D printing gets a lot of questions. The best analogy to 4D printing is in biological systems. Essentially, we are 4D printers, right? We're built additively, and we modify ourselves over time. So that's the precedent is biology and the living world. 4D printing, in the modern sense, is being able to additively manufacture components that can assemble themselves or modify themselves over time, right? So that you don't have static products now. This product can move and adapt not just in terms of its software interface, but in terms of its physical interface. And there's a researcher at MIT, Skylar Tibbetts, who we've been collaborating with for the last few years, who's kind of the leading thinker in the space of 4D printing.
So are these products, I mean, would it be okay to give an analogy that they will multiply or mold themselves like cellular organisms do?
Let's say that they'll at least modify themselves. In a certain case, they may multiply if the need arises. So imagine that this table was a 4D printed object, and it was made of smaller components. And suddenly you had the need in this room to have not one large table, but 5 smaller tables. Then they could reprogram themselves to be 5 smaller tables. So in that sense, yes, potentially they could multiply. But the material obviously has to come from somewhere. We're still restricted by the laws of physics.
So right now the appeal of 3D printing is only restricted towards faster prototyping of products. 3D printed objects are still not very attractive, or they don't look like finished goods. At least the ones that we make as hobbyists. So when do you think that will sort of change?
On the consumer side, I agree with you. On the industrial side, we're actually 3D printing final objects that look amazing. In fact, they look oftentimes like something that you've never seen before. So on the consumer side, I think there's technologies coming now. We've been restricted largely to fused deposition modeling and extrusion technologies, and that will advance a lot. I mean, there's post-processing and things that you can do to make it look better, to make it feel more like a finished object, but there's also ways to embrace the fact that it is 3D printed. And maybe this is a new aesthetic of objects that we should embrace. I mean, the worst thing that you can do is take a new technology and try to do what you did before with it, right? It'd be like taking your mobile phone and plugging it into a landline and saying, well, this doesn't work very well.
Right.
So I think there will be some change in perception and adoption of the products being made by 3D printing, because it won't look like what we've had before. And the technologies themselves. I mean, the new Autodesk printer, Ember, is using a DLP technology, which is a liquid resin. It's exposing it to UV light, and it's continuously, essentially extruding a form out of a liquid. And the results are very, very high quality, right? It doesn't have the layers or the readable layers that you typically see with FDM. You get very high precision. You can make very, very small artifacts with it. We're actually printing hair with it. It feels like fur, right? That's the kind of resolution that we can get. So as new technologies come online, I think some of the perception of 3D printing will change. Yeah.
So it brings me to my last question, which is, as a futurist, where do you see 3D printing, say, 20 years down the line?
I see printers being customized or customizing themselves for specific purposes. You know, we have this fascination with the one box that prints everything. And the reality is, and we learned from the first industrial revolution, there's a place in this world for purpose-built machines. So a 3D printer for turbine blades on a wind generator is going to be very different from a 3D printer for digital devices. And printers will have much more intelligence in terms of feedback loops to ensure quality control of the products coming out of them. They'll have the ability to modify themselves depending on the component that they're printing or the object that they're printing, and we're going to have a lot of different form factors of printers, large ones, small ones, multi-material. So it's not going to all kind of look the same, which is our perception now. They all look like these boxes. Something goes on inside of the box and something comes out the other side. There's also going to be a lot of development around swarm printers, let's say, that can organize themselves in order to manufacture larger objects. Because a fundamental limit of the traditional printer is that it has to be bigger than the thing that it's printing. And we need to overcome that barrier very quickly.
Swarm printers.
Swarm printers.
That's interesting. So do you foresee anything like, say, a Star Trek food synthesizer kind of thing happening anytime?
It will happen. It's going to be some time because there's some chemical issues that we have to overcome. At the end of the day, you have to get molecules to bind. And so within a single material system, we're going to have a lot of advances very quickly. In fact, there's some very compelling work going on right now around the world in metals printing, ceramics, polymers, and mixing different materials within a family, but trying to get metals and plastics to chemically bond. One is using ionic bonding mechanisms, the other is using covalent bonding mechanisms. That's fundamental physics. We can't change that. So we need to come up with some more clever ways to be able to mix material systems to print as the replicator in Star Trek does. It will happen, but it's going to be quite a ways down the road.
Cool. That's it. I'm done.
Awesome. By writing small and unintelligibly, I get compression and encryption simultaneously.